Don't need your filling. Thank you. All right, hi, I'm there. Cool, sweet. All right, let me know if my audio sounds insane. I'm gonna try a better microphone. Hi. Okay, sounds good. Okay, great. All right. Let's see. Oh, ha. All right. I'm gonna switch microphones. Sorry, this one's not quite as good, but I want to. There she is. Okay, cool. Sounds still good? Hi. Better? Good. Okay. Sweet. All righty. Yeah, the first mic is better, but I don't want to risk. This one's like flaky, even though the other one's flaky. All right, let's get going. So as noted, I'm not John De Niro. You guys can't see the chat, but I've seen that comment many times. It's me, Josh Hug. We're going to be talking about 61B. Yeah, let's get going. So what is this class all about? Hi, everybody. There are, what, 900 people here. So we didn't really need the webinar. So what's this class all about? I got to tell you. So this class is about two things. You already know how to program. That's the assumption. But I want to make you better at it. And in particular, I want to make you have the skills to, one, write code that runs efficiently. So it's faster. It uses less space. But the other actual more important goal is to increase the time or increase the rate at which you can write good code, right? Your time should be more efficient as well, not just the computer's time. So to do that, we're going to be talking about designing, building, testing, and debugging pretty big programs. We're going to learn a bunch of tools. So we'll be learning how to use Git if you've never used it, which is most of you. We'll use IntelliJ, which is our IDE. So instead of using a text editor, we're going to be using a more real-world tool. We'll have JUnit, which is going to be a testing framework that's the most popular in Java. And we'll also be learning Java along the way, but that's not the focus of the class. And in fact, we're going to race through Java super fast because the assumption is you've seen at least some other language that's similar. Maybe that's Python or MATLAB. So Java is just another language, and we're not going to go into the weird stuff in Java. We're going to mostly stick to the core language features. So I'm assuming you have a solid foundation in programming. So that includes, you should have some sense of what object-oriented programming is, what recursion is, lists, trees, and yeah, that's sort of a high-level summary. All right, I move the chat here so I can see it in case anything breaks. Alrighty. So why should you be taking this class? There are one big reason. It seems like everybody else in the entire world is taking it. So here is the enrollment history of 61B. And you can see that compared to, I started grad school in 2004. 61B is significantly larger now. And Spring 21 alone is, bigger than it was when I first started at Berkeley in 2014, just the semester. So that's, the peer pressure, obviously a big deal. But there's other reasons that are really important. One is that, our life is supported by data structures and algorithms. So as you know, there is autocomplete in Google. So I guess I will risk doing an autocomplete demo. If I go into Google and I start typing something like, what is a, all this stuff. What are the, right? Like you just immediately, everything seems so good. Yeah, what is a fragile school? What is a fragile school? I'm confused. Anyway, I'm kind of curious when I question what that question even means. But the fact that it's able to respond so quickly relies on a certain data structure we'll talk about in this class called a trie. Yeah, it's pretty amazing what is possible when you use the right data structures. What else? Well, another big reason is that data structures and algorithms are a major driver in how society is changing. So we have progress. Some of it's up, some of it's down, but we're moving forward in some way. So one big example, of course, is AlphaGo. So that algorithm that underlies AlphaGo allows you to, or AlphaGo's successors, the more recent algorithms, they can destroy humans at chess, at Go, at all kinds of other games, even StarCraft to some degree. And in many cases, these algorithms are able to do it without even being taught the games. They can learn on the fly. And so this class acts as a foundation for the kinds of things you might try and go learn in 188 or 189 or other machine learning classes. Another big example, of course, if we think about self-driving cars, those are going to be a really big deal someday or other. They're not quite yet, but in another decade, maybe two, that's going to be a big deal. And another example, again, from AI, because I think that's where a lot of the really interesting stuff the last 10 years has been, is things like GPT-3. So if you've never seen GPT-3, it's an AI that generates text. And you can ask it questions like, hey, what do you think about potatoes? And it'll give you answers. But it also has some really surprising capabilities. So let me show you this little demo someone put together when it was first released. So this right here, someone put this tool together using GPT-3 where it could basically code. So you would say, I want a button that looks like a watermelon. And it would write some code for a button that looks like a watermelon. That was its guess, all right? You would ask GPT-3, how about large text that says, welcome to my newsletter, and a blue button that says subscribe. So you give it that plain text input, and it produces you this piece of HTML code, okay? You can see just these different things it's capable of doing. not necessarily very artful, but it really is amazing to me. And 15 years ago, this just seems so crazy. A button for every color of the rainbow, and it produces code for, right? And this is not what this tool was written for. It was built to generate English text, but it trained itself by looking at examples on the internet, and just on its own, it was able to do this. And so I think this is pretty astounding. And while we're not going to be talking about how to build this technology, because this is just a couple levels deeper into the curriculum, by the end of a CS degree, it's not so crazy to imagine you might work on projects like this. And underneath all of this are really important data structures and algorithms to make it work. There you go. Okay, so you asked it for this plain text table, and it was able to do that. So I think that's pretty astounding. So, if you want to be able to have that superpower, our class is a good place to start. Another one, maybe you don't want to, completely annihilate society by building super AIs, and you just want to be a good programmer. So one of the primary mind behind Linux had this to say. He says the difference between a bad programmer and a good one is whether the programmer considers code or data structures more important. So someone obsessed with code might be like, I don't know, tabs versus spaces, or like, can you fit all your code on one line, or use ternary operators, or whatever other obscure syntax feature. But good programmers worry about data structures and their relationships. And this is something that will be really, really important to you when you do project 2 in this class. So being an efficient programmer really boils down to using the right data structures and algorithms for the job. All right. Uh-oh. Do we have is chat going bad? No? Okay. Anyway, I don't know. TAs let me know something's going. We have a. Okay, let's see. All right, I'm gonna look at my Slack real quick. Okay. Let's see. Okay, looks like everything's still okay. All righty. Another reason is to understand the universe. So these days, science is more about simulation and complex data analysis rather than Newton's law or whatever. So here's an example showing. I got to change my sharing settings so it's smooth. One moment. Okay. So this right here is a simulation of galaxy formation. And so basically, you set up a bunch of rules for how you think the universe started forming, and then you run these simulations, and you're trying to understand the universe around us. And so if you run a simulation like this, and you can recapitulate features of observed galaxies out there in the world, you can say, okay, I have the right physics down, right? Like there are a lot of debates out there in physics about why it is that galaxies spin at the rate they do. You have dark matter. There's other ideas like modified Newtonian dynamics. And if you want to try and tease out what's right and what's wrong, it's actually simulation tools like this that might be able to elucidate which answer is correct. So again, using tools from this class. So here, writing a simulator like this for gravity that's efficient would require you to use tools like what we'll talk about later, something known as a KD tree. All right. And lastly, among things we might do in terms of programming is we might just be interested in creating beautiful things. So I will, I know it's a little laggy, but this is a simulation of fluid flow. And if you just want to make weird fluid flow simulations. Okay, so if you want to simulate cubes of broth being shot into an invisible cube and watch liquid slosh around, this is a class that will, again, lay the foundation for being able to do that. All right. Anyway, so you can check that out later. All right. And one last reason. Okay, hold on a second. Who's spamming us with merchandise here? What? I don't know if everybody can see these posts here. All right, let's see if I can remove this human. One moment. It's not there. All right. Really annoying. Okay. Anyway, all right. Not sure why someone else is allowed to post. Anyway, I'm incompetent, but let me know if it becomes too annoying. All righty. Yeah. All right. So let me move this. So one last reason you might be curious about algorithms and data structures are because we want to study just the math that pops out of data structures. So here on the left is this house. I don't know if any of you have ever tried to draw this little house. And turns out it is possible to do so without picking up your pencil. And this is actually an important problem in the history of graph algorithms. And is originally based on someone's observation that these 7 bridges in the town of Königsberg, it seemed like there was no way to cross them all without using any bridge twice. And indeed, it's not possible. And the underlying graph theory that we'll talk about later in this class will tell you why that is the case. Like, why is it possible that you can't cross all these bridges without using any twice? But it is possible to draw this house. Right. So one thing I'd be curious about here is why are you here in this class? So I'm going to try opening up my polls here. Do I have my questions? Will it let me? My Q&A question. All right. It won't show up. Rats. I wanted to know why you're taking the class, but I don't know how to show it. Okay. All right. Well, so be it. Let's see. All right. You know what I'm going to do instead of? All right. Yes. You know what I'm going to do instead of asking this question? I'm going to proceed. Let's see if I got any. Okay. Thanks for that note, anonymous attendee, about the gray box. I'm going to skip forward because I do not have the technology know-how to make that work, but I do have a question for you. So I'm going to try doing a poll. My first question is, what year are you? I'm going to try and let you guys see who your fellow peers are in this class. So I've launched a poll, and I'm curious. Oh, wow. The clicks are coming in fast. Okay, can you see the answer of the poll as it goes? Oh, yeah. Grad students take this class all the time. All right. Okay, so we are quite a few freshmen, some sophomores, some juniors, fewer seniors, and a handful of grad students and others. I see a variety of gray boxes. Okay, hold on a sec. Let me end the polling and share the results. There you go. This is who you are. So the gray boxes are anything on my screen. One moment. All right, let me try sharing my screen differently. Okay. There we go. All right, hopefully there are fewer gray boxes. I'm going to try and open up. Okay, that's who we are. I'm going to ask you another question now. Okay, my next question is, have you taken a class that used Java before? Okay. And in the meantime, I'm going to try and join our class right now on my phone so I can monitor the chat there. Okay, I'm going to end the polling and share the results. Okay, so we're about half and half. And that's in line with what I've seen in the past. So if you're somebody who is worried, like, does everybody already know Java? The answer is no, but half of them do. But the class is built assuming you don't know any Java. Though the very beginning, the first 4 weeks, well, certainly, I will give you a warning. If you've done Java before, the first 4 weeks might seem easier than you expected, but it will pick up from there. And for those of you who've never done Java, the class is hopefully calibrated properly. So that if you've never done Java ever, that these are doable these first few weeks. All right, last question. I'm curious what prereq class you took. All right. Okay. Yeah, I see the black box. Okay, interesting. All right, here we go, in that poll and share the results. Okay, so most of you came from 61A. 2% of you came from E7, and then 5% of you from 88, and then 2% from a community college programming class. Okay, cool. Okay, let's go away, black box. It's gone. Alrighty, so then now that I know who you guys are, let me tell you about ourselves. So I am Josh Hugg. This is my email address. You can email me if you have questions about things. Here are the tutors. There are too many for me to enumerate. Here are the TAs. There are too many to enumerate. And here are the full-time TAs. And by full-time TAs, I mean people that are working 20 hours a week. So that's our staff, but that's actually not everybody. We also have a bunch of academic interns. Here they are for posterity, so that your name is there forever. So if you ever want to be an academic intern, you could be in a video like this one day, and even more academic interns. So these are all the folks. You can see there's quite a few who are here to support you. That's because there are somewhere on the order of 1,700 people in the class. So these are all the folks that will be helping you out. All right. Let's now talk learning philosophy, because I'd like to give you some insight into how I think about teaching. Oh man, technology. Okay, there we go. Okay, so I'm gonna have this here so I can monitor chat. So learning philosophy. I have found that students, especially those of you who are freshmen, have this false idea about how learning occurs. And it's that you like watch all the lectures. And like when you study for exams and you see that you're not getting results, often I find that it's because people like, they didn't go about learning the right way. Instead, what they did is they watched the lectures and they watched them again, but they weren't really getting most of their learning done. So to me, learning is done through doing. So I have a little example here. Where on the left, this is an example of someone playing Dance Dance Revolution for the first time. It's not too loud. So they're not quite very good at this point in their lives. And I'll tell you why I'm thinking about it. Okay, so I myself, a long time ago, played Dance Dance Revolution a lot, like when I was, I don't know, 17, 18. And I started at roughly the skill level of the folks on the left. And by playing this game literally every day for like 2 hours, this is how I learned that you get better at things by actually doing them. Because I just like, I never had that experience before playing Dance Dance Revolution. So I eventually got to, roughly this level of skill. I'll leave the sound very low. And actually, in the fall last year, because I did this, someone invited me to the HKN held a DDR event in which I was able to still be somewhat competitive with people half my age, but it was pretty fun. Anyway, so I mean, I didn't quite get to this level. I was never a bar holding guy. Just didn't feel dignified, but I got better at it. So because of Dance Dance Revolution, I came to understand that you actually get better at things by doing them. So how's that relate to our class? Well, I would say the small minority of your learning in this class come from the lectures of the reading. I put an insane amount of time into these lectures to make them as good as possible. But to be honest, it's just where you get the intro. The vast majority of where you get things into your brain and really understanding them are, well, when it comes to the theory of the class, from the discussion sections, the study guides, I'll tell you what those are, and the theory homework. When it comes to programming, tool usage, and problem decomposition, something I'll be talking about later, that comes from labs, coding homework, and the projects. And then when it comes to how do you design systems, again, it's the projects, especially 2 and 3. All right. Okay, now I got the most boring part of the class to talk about, the logistics. Okay. So this entire class is built to get you to work on really hard programming problems and have to do some decomposition and design along the way. So because the projects are big and because there's so many different pieces to this course, it can be a little bewildering. So just to navigate everything, I should note that in terms of official course resources, the course website is the main place you'll go to for everything. And since I'm done with videos, let me switch my sharing settings to optimize for high quality. So this is the website. This is the Spring 19 website. So let's change forward in time. So this is where everything is. And there's an announcements box at the top, and pretty much everything you need to know is here somewhere. Okay. There's also lectures, discussion, labs, and office hours. And there's also a discussion forum. So all of you should have already been invited to our discussion forum. If you have not, well, click this link in the slides, which you can find on the website, and join. And there's also a mini textbook, which is just the exact same thing as the lectures, but in text format. You might find it useful. You're also welcome, of course, to use unofficial resources out there. You can Google things. You can go to Stack Overflow. You can go to other programming courses on the web because you don't like the way we teach. And we'll allow you to do that. That's fine. Now, in terms of logistical details, if you are currently waitlisted, I think we're going to get everybody in. Looks pretty good right now. My usual promise is that if you do project 0, then I'll do what I can to get you in by week 4, but I can't give any guarantees. We'll see. To sign up for discussion or lab, there's a thread here. You should have already received an email. If you didn't get that email, then make sure that you're signed up for Ed and have email. You can receive email from us. Now, if you have some administrative issue, like you're waitlisted or anything that's like complicated and logistical, please post either on Ed or send an email to cs61b@Berkeley. I ask, unless you really need something specifically from me, don't email me with admin stuff or logistical stuff. And the basic math is just that if you have 1,600 students and I spend a minute per student, it would take 26 hours. So if we just did a Zoom call where I had 1 minute appointments to get to know everybody, it would actually take more than a day. So I'm happy to take emails about things, by the way. Like, feel free to email me. Please do come to the live Q&As. But if you have something like, how do we change sections or whatever, like, make sure to go to Ed or email this address, because a lot of people are watching it, not just me. Now, in terms of the course structure, we have a fairly major revision of 61B this spring. I'll tell you more about what was different at the end of the semester, but for your purposes, the class is in 3 phases. Phase 1 is an intensive introduction to Java, where we're going to teach you all the Java you need to know for the class. And if you've seen Java already, this part of the class will be somewhat relaxed. And if you've never, it'll be pretty fast. There's one browser-based programming homework. This is homework 0, and it's optional. It's on the website already, and it basically shows you how to do like if statements in Java. I'm not going to do that in lecture because it would be really boring to watch me re-explain for loops, while loops, if statements, and all that. You've already seen all that stuff before in some other language. There'll be 4 labs that are going to introduce you to various tools, like how to use our IDE, including what an IDE is. We'll have 2 projects, Project 0 and Project 1, and they'll both be, I'd say, fairly challenging. And there will be a midterm, which will be on February 10th at some time that we don't know yet. Then we'll have part 2. So this is going to be weeks 5 to 10. This is the data structures part of the class. This is the most important stuff for a job interview. So if you're going to be applying to internships or whatever, this is the questions people are going to ask you. Hash tables, binary search trees, heaps, that kind of thing. During this time, there'll be 1 programming homework, homework 1, and there'll be an exam preparatory theory homework, which is homework 2. There'll be a large solo project, project 2, and you're going to have basically 4.5 weeks to work on this thing, and it'll be quite large. It's a solo project. There's going to be a checkpoint and roughly in about a third of the way through to make sure you're making some progress. But it's a big project, and we'll be talking about it later. During this period, labs are, well, the first lab is going to be a peer review on your first project. There'll be 2 labs where you implement a couple of data structures. And then the remaining labs will be focused entirely on project 2 because it's so big. And there'll be a midterm somewhere towards the end of this phase. And then in the last phase, we're going to talk about algorithms and software engineering. So we'll talk about sorting and some other algorithms, but we're going to primarily be focusing your time on project 3, which is called Build Your Own World. This is a project I'm now running for the 4th time. It's an open-ended project where you're going to build a 2D world. You have basically your own decisions about what you even want to build. And it's been such an enormously successful project. Students really like it. And it's a nice capstone to the end of the semester. Labs in this part, again, will be devoted to the project, and there'll be a theory homework in there. Okay, so that's the framing. So if you want to know where we are, I'll be announcing as we move through these phases when we've reached a new one. But that's what we're going to be doing, these 3 things. All right, more boring logistics. Lab and discussion attendance, they're not required. If you do go, cameras have to be on to attend. Why? Well, okay, 2 reasons. 1, we think it increases engagement. And 2, being a TA with a bunch of people with their cameras off is a little demoralizing. And if just a couple people have their cameras off, there's like this insidious effect where you're like, well, their camera's off, so I'm gonna turn mine off too. I don't mean like, I mean, get away with that. And nobody wants to be like the only 2 or 3 people with the camera on, so eventually you just sink down to no cameras. Now, if you do not like that, if you're like, well, I don't want to have my camera on, there's offline versions that will be provided. And if you really, 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 really want to attend sections like live, because you like the experience of it happening live and you want to be able to chat, in that case, we can maybe work something out if maybe you have like terrible internet or something like that. So, but the default position is that everybody who's in a live section, the camera's on. Otherwise, the offline version is free, or the pre-recorded version. All right, labs, I should note, those are always going to be due Friday at 11:59. They'll be full credit if you have reasonable effort. So you only have to pass some of the autograder tests for full credit. Though I should note that most labs in this class are not, most of them actually don't have anything to turn in. But those where you do have something to turn in, it'll be reasonable effort based. All right, in terms of collaboration policy, you will be submitting your own solution to all homeworks, projects 0, 1, and 2. For labs, you can have a partner if you want. And for project 3, you must have a partner, with very few exceptions. All code on any of these solo assignments has to be your own work, but it's okay to discuss with others and even help other people debug. There is an incredibly long collaboration policy on the website that you will read. And in order to get your account for this class, you'll have to do a quiz on it. So I won't go into it right now, but be aware the collaboration policy is a thing. Gotta move this. Okay. Another feature of the website I want to highlight that is easy to miss is the weekly survey, which is due every Sunday. So we have a survey that you have to do every week. Luckily, it's short, but we do it because we want to check in on how people are doing. Are you keeping up with the class? What do you think about the materials? And we actually look at it every single week. We see what feedback people had for us, and we adjust the course as we're moving. So if it seems like everybody's just a little burned out because coronavirus, online education, whatever, we do change things on the fly. So these surveys are incredibly important. So important, they're actually part of your grade. There's no late submissions allowed, but we will drop your lowest 4 if you miss them out of 14. And those will be linked on the website in the leftmost column. You'll see them. Another thing is on the website, there are study guides for each lecture. This was something I built when I was still at Princeton in response to the question like, well, how do I study for the exams? Like, how do I know what's important from the lecture? So these study guides will provide a brief summary of the lecture, and they'll provide some problems for exam studying. Now, these problems, this is not an exhaustive list. It's just a set of problems that me or my TAs thought were interesting. I will note that the A-level study guide problems are hard enough that the TAs will think they're hard. So be nice to them if they're stuck on them and you're talking to them in office hours. Each study guide also includes a check-in exercise. You don't get any credit for doing them, but they're useful. So let me show you one example of such an exercise. We'll go to the fall website. So in the fall, we have these weekly surveys every week. Make sure to do those. And for each lecture, there's a study guide, which explains a little bit about the lecture. And there's a check-in exercise that asks some questions. So whenever it's on your end, it'll say things like, like this stuff, right? You got to answer these questions. And again, there's no credit for this, but we put these out there. Oh, you probably can't even see what I'm doing. Sorry, 1 sec. My fault. Okay, so what I was just showing was that in the study guide, there are check-in exercises. And when you click these check-in exercises, you'll be able to do some exercises that go over the most important points of that lecture. And again, these are totally optional, but it's a way to, when you're done with the lecture, feel good that you have understood the most important points. Okay. All right, sorry. I often have a second computer up so I can see what's going on my other screen, but I do not today. So I'm kind of flying blind here. All right, exams. So exams, they're closed note, but we'll have cheat sheets, 1 per exam. So an exam when you'll be able to bring 1 handwritten sheet. They're pretty hard. And this is because if I have a median of around 65%, which is typical, I mean, I pretty much hit it almost every exam, then you actually get a good separation between people who have mastered the material, people who have the decent fluency with it, and people who have no idea what's going on. If I set the median at 90%, which maybe felt good, or 85 or whatever, maybe that's something you experienced in high school or maybe other classes at Berkeley even. I think the issue is that on the high end, there's severe clipping, and we can't tell who's mastered it from who just has like core competence. So that's one reason, is we want to provide you with that feedback. And for whatever reason, I mean, society has decided that we have grades, and so we need to be able to separate those 2 classes of people. So I know it's stressful, sorry, but yeah, just be used to the idea that if you get a 65% on the exam, I think you did great. You're doing good. Now, if you show improvement on the final, we do have the ability to boost your overall exam score. I won't go into the exact mathematical details, but if your final is statistically better, you can replace, actually, we changed this policy for coronavirus. So I have to edit my slide right now. Let's do it. It must be corrected. Okay, here we go. I can replace both of your midterms. Okay. This is a new coronavirus temporary thing. In terms of exam dates, they're listed on this slide. I will not enumerate them, but I will say that we will accommodate time zones. So if you're in some time zone far from California, don't worry. We'll make sure to handle you elegantly. In terms of grades, all right, this class is out of 12,800 points. Your letter grade will be determined by your total, and that's basically it. So there'll be some letter grade bends, and if you have whatever number of points, that's your grade. So these are the breakdowns of the points per category. I will not enumerate them out loud, but I will note there's extra credit for surveys, for project checkpoints, and for stretch goals on projects. And all of that will be kind of, as these things come out, we'll say, hey, there's some extra credit. Now, I don't curve. The only thing that's curved, I have to be honest, there is one thing in my class that's curved, which is how clobbering works, but it's not significant for most people. So it is true that how other people do on the final does affect your exam scores to some degree. And it's an annoying side effect of clobbering. One day I will eliminate clobbering so that I can say the class is truly uncurved, but hey, it's just a reality that we're slightly curved. But I don't change the bends. So last semester, I did have to adjust them because I messed up in advance. But what I don't do, or I really, really try not to do, is, okay, I have this many A's. I'm going to move the bends down, right? Because then the class is basically curved. I don't know. You could argue it's curved, but I don't like it. It makes me uncomfortable. I want this class to feel like what you achieve is your grade. And it's not that, everybody else is stressed out about coronavirus and you weren't, so you did better. Like, that's just, I don't want to make, like, my grade bends, I set them at the beginning of the semester. And I really try to stick with them, and I've historically done pretty well. All right, lateness. All right, almost done with logistics. Sweet. No late work is accepted in the class. Now, there are slip days, but basically, if you go over the deadline and you don't have an extension, then we're not going to take it. So we're not dropping homeworks, we're not dropping labs, we're not dropping projects. I really think all the stuff in the class is good, so why drop it? So treat the deadline seriously. But if you really need to, there's an automated extension system called Beacon that we'll be explaining later. You'll get up to 6 total slip days. You can use up to 3 per assignment. So yes, you could technically burn them in the first 2 assignments. Don't do that. And I should note that this is a somewhat generous policy. And I just want to reiterate that this is something that I've decided to do because the material in 61B, it's natural to allow a fair amount of flexibility. Other classes, like say CS70, they're very strongly cumulative, so that if you get behind, like, you're just lost. 61B is not quite like that. So I have a little more flexibility. So I just want to put that out there. You might, like, don't get grumpy at other instructors for not being flexible as we are. Now, if you are really in dire straits, like I used all my 6 slip days, like I have coronavirus, I'm like, recovering, whatever, of course we'll work with you, right? The goal of these deadlines is not that people who can stay on time get better grades. The goal is instead to motivate you to keep up with the class. That's why. So we will have flexibility when necessary, and the primary mechanism, if things break, is you will have a mentor GSI. So if you don't pick a mentor GSI, we'll pick one for you. That'll happen in week 2. They'll keep track of your progress and reach out if they feel like there are issues. And if you feel like you're really falling behind, then make sure to talk to them. Okay? So we will be flexible if we really need to, but the default assumption is that you get 6 slip days, and the vast majority of you, that should be more than enough. Okay? Last thing, until we start doing some programming today. So the class starts really fast. Okay, so just be aware, right? Like, we're just going to hit the ground sprinting. So there's already a homework 0 out, and it introduces you to basic Java syntax, and it'll take 1 to 4 hours, and you should work with friends. If you find this homework really, really hard, then you should seriously consider maybe whether or not 61B is right for you. Yeah, you can persevere even if it's really hard. But I think this homework is intended to be just, you're transferring your prior knowledge to Java, so it shouldn't be so crazy. I really recommend that you complete this before you go to lab and before you go to lecture Friday, which, by the way, is going to be fully pre-recorded. So this Friday is just going to be me doing like question and answer. So I'm not going to go through the whole lecture again. But before you watch Friday's pre-recorded lecture, watch homework or go through homework 0 so that you have the basic Java syntax, because I'm not going to do it in the lecture video. Lab 1 and Lab 1 setup, these should both be available. I'm not 100% certain they're published, but they're internally at least released. Lab 1 setup shows you how to install all the tools you need, and Lab 1 tells you how to use them. The last thing is that Project 0 is coming out this Friday, and it will be due the following Friday. And it is not easy. So I recommend that if you do not know Java, you should really start this weekend, this Saturday, if you have the availability to do so, so that by the time Monday or Tuesday roll around, you have some sense of how you're doing, and you can go to office hours if you need to. It goes through a lot of the basic Java features. And if you want full credit, the last like 6 to 7% of the grade is a pretty challenging algorithmic problem. And I'm not going to talk, I'll say it out loud. The project is implementing the game 2048, but just the core algorithm of it. And I think it's a really cool project, but it will be hard. Even if you know Java already, the tricky algorithmic problem, I think you'll find pretty tricky. Okay, so that's that. Let me see if there's any Q&A questions that I really need to answer. Proctoring policy. We're still internally deciding. Let's see, what else? Is there a lab due this week? Well, there's a lab you should go to this week, but it'll be due a week from Friday. Lab and discussion start, lab this week, discussion next week. Why not use Piazza? Our students liked Ed better. We had people vote last semester. They liked Ed better. So did the TAs. Why not B courses? Because it doesn't do all the stuff we want. Let's see. Okay, that's the key questions that I got. I will talk about the differences between this version of 61B and last fall at the end of the semester. If you do well in your final, it can replace both. All right, so let's do some programming. Let me get my cheat sheet so I don't forget to do anything. Alrighty, so we're gonna write our first Java programs here. And let's just do it here by opening up a couple of text files. Okay, so what I'm gonna do is I now need to share my whole screen. And let's see, I want to minimize this guy. Okay, that could be on the corner. I don't need me anymore. Okay. All right, what I got here is on the right. I'm going to write myself program in Python, and on the left, I'll do Java. So, I'm not assuming you know Python, but it's a language that's so simple that I can use it as a foil for my programming exercise here. So this is a program in in Python that prints hello world. So if I run this in Sublime Text, I need to change one thing real quick. Then I'll get at the bottom, I'll get hello world. Whoa. Why is that running? Okay, there we go. Okay, so this program prints hello world. Great. If you knew MATLAB, well, it's probably something pretty similar. I haven't written MATLAB code in a long time. On the left, I'm going to write a Java program that does the same thing. All right, that's my goal. Let me just check this chat, make sure everything's visible. Great. Okay, so on the left, I'm going to try and do print hello world in Java, and it says error, right? And the problem is that I am trying to compile Java code or trying to compile Python code in Java. So if we look at the message we get back from the Java compiler, it says error, class, interface, or enum expected. And what it's saying is you can't start a Java file with something that's not one of these three things. Well, what's a class? That's the main thing we're going to work on now. It's something that we declare, like you saw in your previous programming class, hopefully. We're going to declare a class here, and I'm going to call it hello world. And in order to make my class, I'm going to do these curly braces. These curly braces indicate the beginning and end of something. So I'll reflect a bit on that. All right, I'm going to try running this code now. This time I get main method not found in class hello world. Please define the main method as this. Okay, so I will do that as the compiler asks. And now when I run my code, I get nothing. It's finished. Great. So in other words, this program on the left is the same as this program on the right in Python, right? So Java, a little more verbose. Okay. Now this is actually a great thing. We'll be talking about what all this stuff means in lecture 2, but for now, we're just going to take it as mysterious stuff that has to be there, the magical letters that must be typed for the program to work. Oh. So then if we try to do print, we have two problems. The first is we need to end all Java statements with a semicolon. And the other is that we have to use the version of print for Java, which is system.out.print. Okay. And I'm actually also going to do ln. Actually, I won't first. So it'll print out hello world, but I also want a new line. So I'm going to do ln. And so once I do that, hello world is on its own line. Okay, great. We have written our first Java program. So let's observe some things about Java. 1, all code in Java must be part of a class. That's one of the rules. Okay, why? That's how they designed Java. Seems weird, but it's, I think, a good choice for what Java is for. Java is a language that is intended for large software projects, and so forcing everything to be part of a class leads to better outcomes overall. That's just a decision that they made. Next thing, we delimit the beginning and end of segments of code with curly braces. 3, all statements in Java must end in a semicolon. Okay. And lastly, for code to run, we need whatever this is. Okay. We don't know what it is yet, but it has to be there. Okay. Some interesting observations about Java. Okay, let's do something else. Let's write a new program that is going to do, we're going to call it hello numbers. All right. Okay. So hello numbers in Python look something like this. Let's see. Right, what do I want to do? Oh, wait, 0 to 10. So I'm going to say x equals 0 while x is less than 10. Let's do print x equals x plus 1. All right, let's run this program and we get, hey, the numbers from 0 to 10, well, 0 to 9. How do we do that same thing in Java? Well, glad you asked. So again, I need to have all this stuff. So let's copy it from the other file. And then I'm going to do the following. I'm going to say x equals 0 while x is less than 10, curly braces, because it's just the way of doing things in Java. Then I'm going to do system.out.println x. Then I'm going to say x equals x plus 1. All right, try running this, and we get error, cannot find symbol. Okay, well, that's mysterious. What is this all about? Well, the issue is that Java doesn't let you just say something equals something. It has to know that something exists first. So what I'm going to do is, on this line, I'm going to declare x exists and is an integer. So if I do that, now my code works. Okay, so it's a little more verbose. It has this funny thing that I had to say what type the variable is. And if there's one thing I love about Java and that other people hate about it, it's that it is statically typed. Types must be declared, and I think that's a beautiful thing. Very important. That's the #1 reason that I like Java. So let me tell you some facts. Before Java variables can be used, they must be declared. Java variables must have a specific type. And what else? Java variable types can never change. So if down here I try to do x equals horse, it will yell at me, and it will say, sorry, you can't do that. Horse is a string. That's an integer. Python, no problem. Great, do it. There it goes. Now it's a horse. So in Java, can't do it. If you try to do string x equals horse, that's also not going to work. It'll say x is already declared. Okay, so the types can never change. Can't do it. Now here's the other thing, and this is a really big one. In Java, types are verified before the code runs. If there are type issues, the code will not compile. Okay. So what I mean by that is when I say x equals horse over here, oops, you'll notice there's no output, right? It just says sorry, like you can't do this. It doesn't do any printing. This code never ran. If by contrast, Python has type errors, like I can try and say like print 5 plus horse. That's a type error. And so if I run this code in Python, you'll notice something happens, right? The numbers actually get printed, and then the error occurs, right? So this actually happened, and then the type error occurred later. And so this is a problem in some ways for Python. Python code can crash due to type errors when it's running. So e.g., if someone is running a spreadsheet, or I don't know, running a version of TikTok or whatever on their phone written in Python, which is not possible. But if it could be, then it could crash in the middle of making a sick dirt bike video due to type errors. Could happen. Yeah. Java, classic error that can never happen. Okay. Next, functions. So I'm going to write a function in Python to give you a sense of how to write functions in Python. So if you want to write a function in Python, you use def. All right. We're never going to use Python again beyond today, but now you know. This is a function that's going to return the larger of x and y. So if x is greater than y, we'll return x. Oops. Otherwise, we'll return y. So if then I say print the larger of 5 and -10 or whatever, I'll get 5. Okay, one more then. Let's do it in Java. Larger demo. And I'm going to copy all the stuff. Larger demo. Okay. All right. I want to declare a function. How do I do that? It's not def, but rather it's public static something larger x, y. Okay. So public static you can think about as the equivalent of def for today. So to declare a function in Java, use public static. Now, one thing that's a little funny is, I'll get to that in a minute, actually. So declare a function, use public static for today. Later, we'll see other ways to declare functions. And here, the code will look like this. If x is greater than y, return x. Otherwise, return y. Now, one thing is, like variables in Java, parameters, which is another kind of variable, also need types. So I'm going to say int x and int y. And then the other thing we need is a return type. We need to say what type the function actually returns. So if you give it two integers, it's going to give you back an integer. So this is the return type. Okay. So I will note here, all parameters of a function must have a type, and the function itself must have a return type. Once all is said and done here, then, assuming I didn't have any typos here, I could say, what's the larger of 5 and minus 10? So I run that, and I had an error. Okay, because I forgot to close my comment. All right, so I get 5. So it looks like it's working pretty well. Okay. One other thing I want to notice real quick is you can't put your function out here. Like that function is not inside of the class. I get that same error. Class interface or enum expected, right? So this function has to actually be part of that class. And that's something we'll be kind of playing around with a little bit in lecture 2. But all functions must be part of a class. In programming language terminology, a function that is part of a class is called a method. So all functions in Java are methods. Okay. Now, you'll notice that's not the case in Python, right? I can create a class called x or whatever, and then put a function inside of it. But you don't have to have it inside of a class. Java, you do. Okay. And again, it's a constraint, but one that's important, something that makes life better in the long term. Now, I should note something really, really, really important, a big downside of the Java type system. Let's say I want to know the larger of 5.5 and minus 10. Well, now I run into trouble because 5.5 is not an integer. So if I wanted to support integers, I'm going to have to maybe potentially write multiple functions, one for integers, one for doubles. A double is just a word for a real number in Java. But that's just something you live with, right? So I won't go into that in much detail today. But be aware that you really do have more verbosity in Java, and you might actually end up with multiple functions like so. So maybe I need another one that handles real numbers, another one that handles integers, another one that handles strings, right? Like this is the downside of Java. And one of the things you have to work around in a statically typed language is how to deal with this, right? So this is something else you could do. Whereas in Python, of course, I can actually do print larger of horse and zebra. And this function works out of the box. I don't have to write a separate string function. Okay, so there's pros and cons. All right. So to wrap up today, let me tell you just a little more. All right. So to summarize the key things that I want you to keep in mind with Java, which, by the way, you should really, like right after this, go start working on homework 0. Post on Ed if you get stuck. Java, the key things you need to know are it's an object-oriented language with some very strict requirements. Every Java file has to have a class declaration. All code has to be inside of a class, and that includes helper functions, global constants, whatever else. And to run a Java program, you will typically have a method that looks like public static void main string args. Okay? So just these are things you have to accept. That's how the language was designed. Next thing is that Java is statically typed. Variables, parameters, methods have a declared type. Type never changes. Expressions have a type. So this entire expression, if you evaluate it, is a type which is integer. And all those types are checked before your program ever runs. That's unlike Python, where the checks happen as you're running. So there's some good and there's some bad things about the way that Java was designed. So just to mention why it's statically typed, one good thing is that it catches some errors so that it's easier for you to debug. You don't get stuck with some weird, like, you have the wrong type error because it's impossible. On an end user's computer, you shouldn't get type errors because they're all checked. Your code is this is the thing that I love the most, this third one. It's easier to read and reason about code. You know what everything is. And so when you have weird arcane types, which we will later in this class, you know exactly what you're getting. When someone gives you X, you know that it's a potato or a horse or whatever, or an integer. And lastly, your code can actually run more efficiently because of the fact that under the hood, there's no type checks going while you're running, for example. So it just turns out that statically typed languages tend to be faster. But the bad thing is your code's more verbose and it's less general. You have to have maybe 2 or 3 or more larger functions. All right. So that's it for today. I will stick around for a minute to take questions that have popped up in the Q&A, but I'll just note this week, homework 0 is out now, and I really want you to go work on it. Like, I've just shown you some Java, but you didn't absorb it. You know, like you got some of it, but where you're really good at is doing the assignment. And if you've already done Java before, I still think going through this exercise is useful just to get a sense of what you should be expected to know. Lab 1 is how to compile and run your code and also how to use the IDE. It tells you how to check out the homework files and how to submit them. And if possible, really try to do homework 0 before the lab, just so that you've had some Java experience. Lab 1 setup, which I recommend doing before lab. It tells you how to set up your own computer. And Project 0 is not going to be released today. I think it's actually going to be Friday. That's going to be done solo, so be ready to start working on that. And then next lecture, I'll be talking about what public, static, and so forth actually mean. So if you'd like to stick around, I will answer a few extra questions here. So let's see. Here we go. The lab setup. Should you complete it before the lab session? If you can, great. Can you use Java? Can you program in this class in the terminal? Technically, yes, but I strongly discourage it. IntelliJ is a great tool to know how to use. I am a convert. I was always a diehard terminal text editor person, but I was convinced by IntelliJ. Can you join Ed if you're auditing? Yes, please do. Slides for today, they are already posted. Can we use interpreters for exams? Like a translator? Unclear. Not sure. I'll have to talk to my TAs. Are you expected to do lab assignments before lab? No, you are expected to do them in lab, though I encourage you to do lab 1 setup before. Let's see, what do we got next? How do we run programs in Sublime? I will not reveal the secret other than I'll just show you briefly, but it's not something you'll ever do in this class. So if I'm sharing the right screen, right here, if we go to Tools, Build System, it's something I set up here in a build system. So once I do that, I could do Control B. So if you want to learn how to do that, go for it. But I don't want to teach it because I want you to use IntelliJ. Let's see. Why Java over Python for 61B? Java is a better software engineering language than Python, mostly because of the static typing. Let's see. Can you do everything on a MacBook? Sure. Windows, MacBook, all good. Let's see. Does the name of the class have to be the same as the name of the file? Yes. Why did you not have to write system.out.println on the right-hand side? That's because it was Python earlier. Let's see. Can we declare variables outside the class? Nope. All variables have to be in a class. Let's see. Will CS Scholars have lab this week? Yes. Will GitHub problems that will have to push beyond midterms? There's no interaction between GitHub and midterms. I don't quite get the question. First lab on Zoom or Discord? I believe it will be a hybrid. There will be a survey after Sunday. This is weird. It's like talking to myself. Is it possible to audit the course? Yes. If you want to know order to tackle things, then someone asked, there is a getting started guide, which I will point you to. So getting started guide. Yeah. Let me share my screen properly. If you got to go, by the way, feel free to go, and this will be posted on the website. So there's a getting started guide that gives a suggested order in which to do everything. Once you get past week 4, it'll be pretty clear. There's no way to submit homework 0. It's optional, and it's all in the browser. Recordings for labs and discussions will be posted on the website. We'll see. Weekly surveys are usually posted, I think, Fridays, and they're due Sundays. There's no survey yet, though. Let's see. Is Adam a good text editor? Sure, but you're using IntelliJ in this class. Lab this week, yes. There are tutors for this class indeed. Can you use VS Code instead of IntelliJ? Probably. We don't officially support anything else, but you're welcome to use other things. Can you take the exams if you're auditing? Yeah, but I don't know if we want to grade your exam. All right, let's see. What should we do before lab this week? Homework 0 and lab 1 setup. Live Q&As we posted in the study guides. I don't know what M1 is, so I can't answer that question. If you can't go to lab, is it okay? Lab attendance not required, so you can do stuff before or not even go. Oh, I see, an online Java interpreter during exams. No, probably not. I don't think it's necessary. We prefer just to read the code you write and interpret it if you're close. I don't like giving penalties for syntax errors. And I find that if I actually let people run code on an exam, it actually causes students to do worse, somewhat counterintuitively. It's a pretty common observation. Let's see. Are there ways to get around making multiple functions? Kind of. We'll talk about that in a few weeks. Are there global and local variables? Any variable which is local to, actually, I'm going to defer that one to the next lecture. And let's see. Right, okay, oh, so yeah, there's no coding for in IntelliJ on exams. It's just, we don't have the infrastructure to support that this semester. And then can you still, oh, if you're cross-enrolled, or if you're any kind of concurrent enrollment, you can submit assignments, join ed, you could do everything. You could just be like you're in the class. If you have any trouble as a concurrent enrollment or cross-enrolled student, just post on ed and we'll take care of you. Okay, I think that's all the questions I can answer since I got to go teach my other class at 3. Lab attendance is needed. Oh, right. There are a few labs where attendance is required, but they're specific labs. There's a peer review, there's a project demo, and I believe it's the design doc review, but I need to look at it. If you really can't do those, and we'll have time zone accommodation for lab demos, but you know, we have them pretty spread out over time. So it's not just any labs, it's some specific labs. Okay, that's it. Thank you, everybody. And I'll see you on Friday. Please come to live Q&A if you like talking, and then you'll actually be able to show your face and like speak out loud. We'll be done with the webinar format. All right, thanks everybody. See you Friday.